Hey everyone, this is Bradley Bush with another algebra video for you. Today we're talking about systems of linear equations in two variables. Our to-do list, first off, we'll have a review of systems of linear equations in two variables. Because we are in two space, meaning we have two variables in our equations, we'll be dealing with the xy coordinate plane there, so that's a little reminder. Second thing is, our focus today will be the one solution scenario. So in these systems, you've got three scenarios: one solution, infinite solutions, and no solutions. And today, in this video, we're talking about the one solution scenario. I've listed all of the components of the video with their timestamps in the description of the video. So if you want to jump to something specifically, please do. Let's start. So what exactly is a system of linear equations in two variables? Because it kind of sounds complicated. So the two variables just literally means you have two variables. Usually we have an x and a y. That's it. So we have an equation with two variables. These equations are linear, meaning they represent a line, and we know because all of the exponents on the variables are 1. And if they're 1, then we don't see them. They're just implied. So we'll never have an exponent bigger than or different than 1. It's always 1. So we've got two lines. Generally, the system in these systems have two lines. So that brings us to what a system means. What does a system mean? A system just means you have more than one of them. So if you have more than one, they call it a system. In this video, all of our systems will have two equations. So we have two lines, and we want to find out where they cross. That's really all we're talking about. So it sounds complicated, but it's not. Here's an example of a system, equation 1 and equation 2. With my equations, I label them with a number with a circle around it, so you know that that number is a label and not a number. So equation 1, equation 2, you can see I've got two variables. Although both the variables have a 1 as the exponent, no big deal. So what does a solution look like for this system? Well, it's any point that satisfies both equations, meaning if you plug that x and y into both the x and y in the system for either equation, you'll get a true statement mathematically, like 2 equals 2 or 6 equals 6. But geometrically, what this means is that you have two lines and a solution is a place where they cross or the lines touch. So again, we have three possible options. The one solution case where they just touch once, the no solutions case because they're parallel and never touch, or the infinite solutions case because the two lines are actually the same line. They lie on top of each other, so any point on one line is also a point on the other. You might think, well, how are these only the only three? Well, by definition, lines are not curvy, so this will never turn around. So if they touch, they only touch once. So how do you know which of these three options you're in when you're solving a problem? That's also pretty simple. Well, you just start solving the problem. And if you get an answer, then you're in option 1, and you've only got one answer, assuming you did your algebra correctly. Otherwise, as you're going along, the variables will cancel out, and you'll just be left with numbers and an equal sign. If those numbers and equal sign make a true statement, like 0 equals 0 or 2 equals 2, then you know you're in option 3, which is infinite solutions. If those numbers and equal sign make a false statement like 0 equals 2, you're in option number 2, which is no solution. How do you solve these types of systems? Well, we have two methods, the substitution method and the addition method. So we'll use the addition method here in the problem that we'll be solving. So this is the one solution scenario. We have a system of equations. We have equation 2, and we're going to solve this by addition. That means we want to add them and somehow cancel one of the variables. So unfortunately, it's not super simple here because the numbers don't line up. If you just add them straight up, you don't cancel anything. You get a 5x and you get a negative y, which doesn't help us, right? But if we did something like if we multiplied equation 1 by negative 2, that would give us a negative 6 here, right? Negative 6x. And if we multiplied equation 2 by 3, that would give us a positive 6x here, and when we added them, we get 0, right? They cancel out. So let's do that. Let's multiply all of equation 1 by -2 and all of equation 2 by 3, and then add the two equations. So what do we get? If we take equation 1 and multiply it by -2, we get a -6x and a positive 8y and a -22. This was equation 1, right? But we'll call it 1.1 because it's changed. It's our new version of equation 1. How about equation number 2? We're going to multiply it by 3. So that gives us 6x. This is looking nice, right? And 3 times 3 is 9y. And then 3 times -4 is -12. And that is equation 2.1. Because it's not 2, but it's the new version of 2. Now when we add them, what do we get? Well, we can see the 6's cancel. That's nice. So we get 0 here, which is what we wanted. And we get, I don't need a plus there, we get 17y equals -34. Now we can solve for y, divide by 17, and we get y equals what? -2. Cool. Y equals -2, so we can take that y equals -2, and we can plug it back into one of the two equations. I choose equation number 2, just because you could choose equation number 1 if you want. So here's equation 2, 2x plus 3 something that used to be a y equals -4, but we're going to plug in a -2 now. And then we're going to solve for x. So what do we have? We have 2x minus 6 equals -4. So if we add 6 to both sides, we get some canceling there, and we get 2x equals 2. This is looking nice, right? And x equals what? Well, if we divide both sides by 2, we get x equals 1. So that's nice. So we got a solution, right? What is our solution? X equals 1 and y equals -2. So this is the place where they cross. And if we look at the graph here of the two equations, we have equation 1 and equation 2 here, and they cross where? Right there, which is 1, -2, which is exactly what we found algebraically. So this was a case study of the one solution scenario in systems of linear equations in two variables, and we used the addition method to solve for the solution, or the point where the two lines cross. If this was helpful, then subscribe to the channel. Thanks for watching, and hope you have a great day.